We're going to talk a little bit more about this, but basically what I just talked about, for example, whether you're doing the whole histogram, the histogram of the whole image, which doesn't work very well, but you could do it, or if you build like these orientations of gradients in each of the quadrants, you're building a model, a description of that instance. Oh, by the way, you take for each of those histograms of four, and you just string them into one great big feature vector. That's your description. So now what you have to do is you have to train, or sometimes referred to as learn, a classifier. Given a bunch of those feature vectors describing koalas and given a bunch of them describing pandas, figure out how to discriminate one from the other. So here's the basic description. All right, so let's suppose we're trying to learn cars versus not cars. So how many classes is that?
2.
Sorry, how many classes are that? How many is that? It is 6. There are 6 classes, but the number of classes is 6. Actually, the number of classes is 2. I don't know. It's called a binary classifier because there are 2 classes. So for example, suppose I have a little picture here of a car, and I have to decide, is it a car? And what do you think? You think that's a car?
Yes.
Good, she got it right. Yes, it's a car. Okay. Now here's another picture. Okay, taken somewhere in China, I think. I don't remember where. Sorry. So is that a car or not a car?
No.
No. Very good. What we need are methods of doing that. Now, there's been a huge effort in machine learning and applied to computer vision over the last really 15, 20 years of methods of doing discriminative classification. What you see listed here are a whole bunch of methods, a couple of references below them, of how to go about doing that. We're going to talk about 3 of them. I've just highlighted them here: nearest neighbor, SVMs, boosting. There are others as well. The general approach, and there's a huge literature on this now, especially with these large-scale object recognition competitions, of what's the best feature vector you can use, learning different feature vectors, sparse representations, a bunch of other things, and then, given those representations, what are the methods that you should use to make the classification. Here are the 3 that we're going to talk about. If you take more machine learning, just remember later, you could apply those methods to those other representations. Our fundamental assumption is going to be someone, and hopefully that's somebody you don't have to pay, but somebody is going to give you a database of lots of examples of the things you want to find and lots of examples of the things you don't want to find, and then you're going to train the classifier. Now, once you do that, you have to come up with some way of given some new image, how do you test it? So you remember we talked about you have to generate these new candidates and you have to score them. So here's the basic idea. You start off with a window, and Kristen is really good at this animation, right? And you might take that window of a particular size and you scan it all over. And what you do is you apply your car, non-car classifier to every one of those windows. And you say, do I see any cars? Do I see any cars? Do I see any cars? Not very clever, but it just works very well, right? Because the classifiers are quick and they're accurate. So as opposed to having a different way of trying to do detection versus labeling, I basically do detection by labeling. There is a problem, of course, though. I picked a window. Well, suppose I'm nearer to a car. Does the picture of the car get bigger or smaller? That one's an easy one, Megan. If I get bigger, does it look bigger or smaller?
Bigger.
Bigger, very good. So what do I have to do? Well, I just have to try bigger windows, and I slide those all over the place. And if this feels kind of data intensive, you're right, and there are various tricks to doing it, but that's the general idea, is that you take these different size windows and you apply them to different places in the image.